Hello dear students. So far in the previous classes, we have to discuss about an atom, in which we discussed about what is meant by atom and different atom models such as J.J. Thomson's atom model, Rutherford's atom model, Bohr's atom model, alpha particle scattering experiment, and the hydrogen spectrum. So these things are we have to discuss in the previous classes, right? Now in this video we are going to discuss about nucleus or nuclei and nuclear structure, and next properties of a nucleus, classification of a nucleus. So these things are we will discuss about in this video or in this class, right? Okay, what is meant by nucleus? Simple. The central core of an atom is called nucleus. The central core of an atom is called nucleus, right? Atom is spherical in shape. There is a tiny central core of an atom that is called nucleus. Right. Atom, the smallest particle of an element is called atom. The atom consists of a small central core in it, which is called nucleus. Right. So nucleus was discovered by Ernest Rutherford. Right. Already you know that the nucleus was discovered by Ernest Rutherford from alpha particle scattering experiment. Alpha particle scattering experiment conducted by his students, namely Geiger and Marsden. So Geiger and Marsden, who are students of Ernest Rutherford, they conducted a simple experiment by using alpha particle, which is scattered by a thin gold foil on the idea of Rutherford. Okay, so from that experiment, Rutherford was concluded that an atom has a lot of empty space. An atom has a lot of empty space. Right? An atom is electrically neutral. Atom is electrically neutral because it consists of equal amount of positive charge and negative charge carried by an electron. Okay? An atom is electrically neutral. Why? Because it consists of equal amount of positive charges and negative charges carried by an electron. So that is why an atom is electrically neutral, and atom has a lot of empty space. Atom has a lot of empty space, right? And the electrons in an atom is revolve around the nucleus in a fixed circular orbit. Fixed circular orbit. So these are the conclusions given by Rutherford from alpha particle scattering experiment, right? So from the alpha particle scattering experiment, Ernest Rutherford discovered the nucleus. So nucleus is nothing but a central core of an atom. Central core of an atom, right? So already I told an atom is electrically neutral because it contains equal amount of positive charges and negative charges carried by an electron. Okay, the electrons are revolved around the nucleus in circular orbit. Right? And the entire positive charge of the atom is concentrated in the tiny central core, which is called nucleus. Not only positive charge, the entire mass of an atom also concentrated in this region. Okay, a small central core of an atom where the total positive charge of the atom and whole mass of the atom is concentrated is known as nucleus. So nucleus is the central core of an atom, right? And this nucleus consists of two elementary particles. Okay, generally atom consists of three elementary particles, namely proton, electron and neutron. So proton, electron and neutron, these are some elementary particles. These particles are exist in an atom, right? So in this atom, The nucleus consists of only two elementary particles, namely proton and neutron. Proton and neutron. So here proton and neutrons are combinedly called as nucleons. Protons and neutrons are combinedly called as nucleons or nuclear particle. Okay, which are nuclear particle? Protons and neutron. The protons and the neutrons are combinedly called as nucleon. The elementary particle of an atom, proton, electrons and neutron. Right? Proton, electron and neutron are the elementary particles of an atom. The elementary particles of a nucleus, proton and neutron. They are combinedly called as nucleons or nuclear particle. Nuclear particle. Right. Okay, here the proton is a positively charged particle. Proton is a positively charged particle and electron negatively charged particle, whereas neutron is a neutral particle. It is a chargeless. So one of the elementary particle of a nucleus is a neutron, which is a chargeless, that is electrically neutral. And another particle of a nucleus is a proton, which is a positively charged particle. And electron is one of the elementary particle of an atom, which is a negatively charged particle. Right? And charge of a proton is represented by plus E. Charge of a proton, the charge of a proton is represented by plus E. And charge of electron is represented by minus E. Okay? What is the value of E? E is equal to 1.602 into 10 power minus 19 coulomb. Coulomb is a unit of electric charge, right? E denotes charge of an electron. Right? Charge of an electron is 1.602 into 10 power minus 19 coulomb. This value was determined by Milligan from his oil drop experiment. Okay, Milligan conducted a very important experiment called Milligan's oil drop experiment. In that experiment, Milligan was successfully determined the value of a charge of an electron. The value obtained is 1.602 into 10 power minus 19 coulomb, right? And here the proton charge is represented by plus E. Okay, because the proton is a positively charged particle. And magnitude of charge of a proton is equal to that of the magnitude of a charge of an electron. But the only difference is that proton has positive charge and electron is negatively charged. But the magnitude values are same, that is 1.602 into 10 power minus 19 coulomb. It was determined by Milligan from his oil drop experiment. So charge of a proton is plus 1.602 into 10 power minus 19 coulomb. And charge of electron is minus 1.602 into 10 power minus 19 coulomb. So electron is negatively charged. So it is a familiar one. So, sometimes we can write the value of charge of an electron is 1.602 into 10 power minus 19 coulomb. But when we compare the charge of proton and the charge of electron, we should write the charge of proton is plus 1.602 into 10 power minus 19 coulomb and charge of electron is minus 1.602 into 10 power minus 19 coulomb. So electrons, neutron and protons are elementary particles of an atom, and the elementary particle of nucleus, proton and neutron. Okay, proton positively charged particle, electron negatively charged particle, and a neutron neutral particle, that is chargeless, right? And due to the presence of positively charged proton in the nucleus is positively charged, right? The entire atom is electrically neutral, but nucleus alone positively charged. Why? Due to the presence of a positively charged proton, right? But the neutron is a neutral particle, it is chargeless. But due to the presence of a proton in the nucleus is positively charged. But an atom is electrically neutral. Why? Because the positive charge of proton in the nucleus is equal to the negatively charged electrons, which is revolve around the nucleus, right? So the total charge of the atom is 0. So that is why an atom is electrically neutral, right? So once again repeat, nucleus is the central core of an atom. It was discovered by Ernest Rutherford from alpha particle scattering experiment, right? The nucleus consists of two elementary particles, namely proton and neutron. Proton is a positively charged particle whose magnitude is equal to that of the magnitude of a charge of an electron. That value is 1.602 into 10 power minus 19 coulomb. And another elementary particle of the nucleus is a neutron. It is a neutral particle. Neutral particle, that is chargeless, right? So due to the presence of a proton, the nucleus is positively charged. The nucleus is positively charged. Generally, the charge of the nucleus is represented by plus Ze. Okay, so this equation is common for all the nucleus, all the nuclei. The charge of the nucleus is equal to plus Ze, because nucleus is always positively charged due to the presence of a proton, right? What is Z? Atomic number. Later we will discuss about that. And E is a charge of a proton or a charge of proton. The value of a charge of proton is a plus 1.602 into 10 power minus 19 coulomb. A charge of a single proton is plus 1.602 into 10 power minus 19 coulomb. Generally, the charge of the nucleus is represented by the equation Q nucleus is equal to plus Ze, right? And nucleus is positively charged due to the presence of a proton, right? Okay, and neutron is a neutral particle, and nucleus was discovered by Ernest Rutherford. The nucleus is the central core of an atom, and around the nucleus, the negatively charged electrons are revolve in fixed circular orbit. Right? Generally, the nucleus of an element is represented by XIza, or otherwise we can write like this. The nucleus of any element is represented by XIza, right? Here X, chemical symbol of an element. Right? And Z, atomic number. And A, mass number, right? The nucleus of any element is represented by the symbol X suffix Z and numerator A, right? Here X stands for chemical symbol of an element, and Z atomic number, and A mass number, right? Now, what is atomic number? The total number of protons present in the nucleus of the atom is called atomic number. The total number of protons present in the nucleus of an atom is called atomic number. It is denoted by the letter Z. So, atomic number refers total number of protons. Right. And what is the mass number? The total number of nucleons present in the nucleus of the atom is called mass number. What is meant by nucleus? The combination of protons and neutrons are called nucleon, or the neutrons and the protons are combinedly called as nucleon. So, the mass number is nothing but the total number of nucleons or the total number of protons and neutrons present in the nucleus of the atom. So, mass number refers total number of nucleons or total number of protons and neutron. Total number of protons and neutron, right? And capital N refers number of neutrons. If you know the atomic number of the given nucleus and its mass number, from which we can calculate what is the total number of neutrons present in the nucleus. Total number of neutrons present in the nucleus. How? By subtracting atomic number from mass number, we can get the total number of neutrons present in the nucleus. Right? Total number of neutrons N is equal to A minus Z. Okay, already I told A stands for mass number, which refers the total number of nucleons present in the nucleus, right? And is that atomic number? Atomic number gives the total number of protons in the nucleus. By subtracting atomic number from mass number, we can get the total number of neutrons present in the nucleus. So capital N, neutron number, capital A, mass number, and capital Z, atomic number, and capital X is the chemical symbol of an element, right? So XIZ-A denotes the nucleus representation of any element. The nucleus representation of any element is XIZ-A, right? Okay, and already I told the nucleus consists of a positively charged proton and neutral charge neutron. The charge of a proton is plus 1.602 into 10 power minus 19 coulomb, whose magnitude is the same as that of the magnitude of an electron. The magnitude of an electron. And the neutron is a neutral particle. That is, the charge of a neutron is 0. The charge of a neutron is 0. Right? Even though the neutron is a neutral particle, but it has mass. Right? The mass of a neutron is 1.6749 into 10 power minus 27 kg. The mass of a neutron is 1.6749 into 10 power minus 27 kg, but its charge is 0. Right? And the mass of a proton is 1.6726 into 10 power minus 27 kg. Right? So mass of proton is 1.6726 into 10 power minus 27 kg, and charge of proton is a plus 1.602 into 10 power minus 19 coulomb, and proton is a positively charged particle. It is one of the elementary particle of the nucleus. And another particle is a neutron, which is neutral or chargeless, but it has mass. The mass of a neutron is 1.6749 into 10 power minus 27 kg. So comparing these two nucleon, the mass of neutron is slightly greater than that of mass of proton. The mass of neutron is slightly greater than that of mass of neutron is slightly greater than that of mass of proton. But it is a neutral particle. This is a positively charged particle, right? So comparing the mass of a proton with the mass of an electron, the mass of a proton is 1836 times of mass of an electron. Okay, then what is the value of mass of an electron? Mass of an electron is 9.1 into 10 power minus 31 kg. Okay, in an atom, the smallest particle is electron. Its value is 9.1 into 10 power minus 31 kg. And another particle of an atom is a proton, whose mass is 1.6726 into 10 power minus 27 kg. And another particle neutron, whose mass is 1.6749 into 10 power minus 27 kg. Among these three particles, the least mass is electron and the highest mass is neutron. Comparing mass of neutron and mass of proton, mass of neutron is slightly greater than that of mass of proton. Comparing mass of proton and mass of electron, the mass of proton is 1836 times of mass of an electron. 1836 times of mass of an electron, right? And the nucleus of any element is represented by XIZ-A. X, chemical symbol of an element, is that atomic number. What is atomic number? The total number of protons present in the nucleus. And A be the mass number. Okay, mass number means the total number of nucleons or the total number of protons and neutrons present in the nucleus. What is the neutron number? The difference between mass number and atomic number is nothing but a neutron number. Okay, if you want to calculate the total number of neutron present in any nucleus, just we subtract the atomic number from mass number. So the number of a neutron is given by the formula N is equal to A minus Z. And nucleus is positively charged. The charge of any nucleus can be calculated by using the formula Q is equal to plus ZE. Right? So why in this equation there is a positive sign? Because the nucleus is always a positively charged. Why? Because due to the presence of a positively charged proton. Here what is a small e? The small e represent the charge of a single proton. a charge of a single proton. What is that? The total number of proton. So depending upon the number of proton present in the nucleus, the charge of a nucleus value changes. So the charge of the nucleus is depends on its mass number. So the charge of a nucleus can be calculated by using the formula Q is equal to plus ZE. Right. Next we go for classification of a nuclei. So based on the total number of protons and neutrons present in the nuclei are classified into three categories. They are, first one, isotopes, second, isobars, third, isotones. Isotopes, isobars and isotones. These three are classification of a nuclei based on the total number of protons and neutrons present in the nuclei. Right. So first we go for isotopes. Right. So what are called isotopes? Isotopes are the atoms of same element. The isotopes are the atoms of the same element having same atomic number but different mass number. The atoms of the same element having same atomic number but different mass number is called isotopes. Or on the other hand, the isotopes are the atoms of same element having same proton number but different neutron number. Same proton number but different neutron numbers are called isotopes. Right. So isotopes are the atoms of same element having same atomic number but different mass number, or same proton number and different neutron number. Right? So what are called isotopes? Isotopes are the atoms of same element having same atomic number and different mass number, or same proton number but different neutron number. Right? One of the best example for isotopes is hydrogen isotope. Right? Hydrogen isotope is represented by 1H1, 1H2 and 1H3. So 1H1, 1H2 and 1H3. These three are isotope of hydrogen. Right. So see here hydrogen nucleus consists of same number of proton. Okay. Here 1H1 is called hydrogen and 1H2 means deuterium. Here 1H3 is a tritium or a deuteron or a triton. So 1H1 is hydrogen, 1H2 deuterium or deuteron, and 1H3 is a tritium or triton. Here 1H1, 1H2 and 1H3, these three are isotopes of hydrogen atom. Right. So in this isotope of hydrogen atom, the hydrogen, deuteron and triton have same atomic number, but different mass number. Right? Hydrogen atom has one proton number, but proton number is 1 and neutron number is 0. Right? What is neutron number? The difference between mass number and atomic number gives neutron number. Okay? So 1 minus 1, 0. So proton number in hydrogen is 1 and a neutron number is 0. Right? In deuterium, proton number is 1 and a neutron number is 2 minus 1. So neutron number also 1. In the case of tritium, proton number is 1 and a neutron number is 3 minus 1, 2. So the atoms of same element having same atomic number but different mass number are called isotopes. Or the atoms of same element having same proton number but different neutron number are called isotopes. Right? Once again I repeat, isotopes is one of the classification of nuclei. What are called isotopes? The atoms of the same element having same atomic number but different mass number, or same proton number but different neutron number, right? Okay, and here the isotopes are the atoms of the same element, so they have identical electronic structure. Identical electronic structure. Identical electronic structure and also identical chemical properties. We know that the chemical properties of the element is determined only by electrons, So in the case of isotopes, hydrogen isotope of an atom, the electron number is the same. If a proton number is 1 means the number of electrons in hydrogen, deuteron and triton value also 1. Okay, the chemical property of these isotopes can be determined only by electron. Here the electron number is the same in the case of isotope of hydrogen atom. So they have identical chemical property. So chemical property of any element is determined only by electrons. So in this isotope, electron number is the same, so they have identical chemical properties. Okay, and also the isotopes are the atoms of the same element, so they have identical electronic structure. Right. And one more thing, the isotopic element are located in the periodic table in the same location. Okay, in hydrogen place. Okay, in a periodic table, if hydrogen is at the top of the table, where the deuteron and the triton also there. Okay, so isotopes are the atoms of same element having same atomic number but a different mass number. So being same element, they have identical electronic structure and as well as identical chemical properties. They are located in the periodic table in the same location. The isotopes are located in the periodic table in the same location, right? So this is for about isotopes, right? And next we go for isobar. One of the example for isotope, 1H1, 1H3 and 1H2 and 1H3. So this is isotope of hydrogen, right? And next isobars, right? Isobars means the atoms of different element having same mass number but different atomic number. Okay, same mass number but different atomic number but different element, right? Isotopes, atoms of same element having same atomic number but different mass number. But in the case of isobars, the atoms of different elements having same mass number but different atomic number. So atoms of a different element, right, having same mass number but different atomic number are called isobars. Okay, isobars are the atoms of different element having same mass number but different atomic number. But isotopes are the atoms of the same element, here different element, having same atomic number but here same mass number. Different atomic number in the case of isotope, in the case of isobar, different atomic number. The best example for isobars is, okay, silicon 1640, chlorine 1740, and next argon 1840, krypton 1940, and calcium 2040. Okay, this is the best example for isobars, right? Here, see here, this is silicon, chlorine, argon, krypton and calcium. Different elements, but they have same mass number, 40, 40, 40. Same mass number. But atomic numbers are different. Okay, for silicon, atomic number 16, for chlorine 17, argon 18, krypton 19 and calcium 20. So the atoms of different element having same mass number but different atomic number are called isobars. Isobar, right? Here isobars are the atoms of different element, so they have different electronic structure. Different electronic structure and different physical and chemical properties. Right? But isotopes are the atoms of the same element, so they have identical electronic structure and identical chemical properties. But isobars are the atoms of a different element, so different electronic structure. They have different electronic structure and they have different physical and as well as the chemical property. Example for isobars: silicon, chlorine, argon, krypton and calcium. They have same mass number but different atomic number. Right? And next, third one, isotones. Right? So simple, the atoms of a different element having same neutron number. Same neutron number, right, are called isotones. Example, okay, boron 512 and carbon 613. B, boron and C, carbon. They have different mass number and different atomic number. Okay, but they have same neutron number. Here 12 minus 5, 7. Here 13 minus 6, 7. So neutron number is equal to mass number minus atomic number. Mass number minus atomic number. So atoms of a different element having same neutron number are called isotones. Example for isotone, boron and carbon. Boron and carbon, right? So these three are classification of a nuclei. So based on the proton number and the neutron numbers of the nuclei are classified into three categories. They are isotopes, isobars and isotope. Isotopes are the atoms of the same element having same atomic number but a different mass number. They have identical electronic structure. They have identical chemical properties, and they are located in the periodic table in the same location. Right? Example for isotopes: hydrogen 1H1, 1H2 and 1H3. Right? Isobars are the atoms of a different element having same mass number but a different atomic number. Okay? They have different chemical properties and different physical and chemical properties. Okay? Example: silicon, chlorine, argon, krypton and calcium. And last one, isotones. Isotones are the atoms of a different element having same number of neutron. Example: boron and carbon. Boron 512 and carbon 613. These two are example for isotone because they are a different element but they have same number of neutron. So this is for about classification of nuclei. Right. Next we go for atomic masses and nuclear masses. We know that the unit of a mass is a kilogram. Another unit of a mass is also there, that is atomic mass unit. In nuclear physics, the nuclear mass is expressed in terms of atomic mass unit. Why? Because the mass of the nucleus is very small. It is of the order of lesser than or equal to 10 power minus 25 kg. The mass of the nucleus is of the order of lesser than or equal to 10 power minus 25 kg. So that is why it is very convenient to express the mass of the nucleus in terms of atomic mass unit than kilogram. So atomic mass unit is a unit of mass which is mostly used in nuclear physics to express the mass of the nucleus. Right. What is meant by atomic mass unit? Atomic mass unit is nothing but 1/12 of mass of carbon 612 atom. Okay, atomic mass unit is represented by small u. Right? One atomic mass unit is equal to 1/12 of mass of carbon 612 atom. One atomic mass unit is equal to 1/12 of mass of carbon 612 atom, or one atomic mass unit is defined as 1/12 of mass of carbon 612 atom. Right? And carbon 612 is most abundant naturally occurring element. Okay, carbon 612 is one of the isotope of carbon, which is most abundant naturally occurring element. Naturally occurring element. 1/12 of mass of one carbon 612 atom gives one atomic mass unit. Okay, atomic mass unit is a unit of mass which is mostly used in nuclear physics to express the mass of the nucleus. To express the mass of the nucleus, right? What is the value of the mass of one carbon 612 atom? That value is 1.9926 into 10 power minus 26 kg. Right? Mass of one carbon, okay, 612 or carbon 12 atom is 1.9926 into 10 power minus 26 kg. Right? Divided by 12 gives one atomic mass unit value. Right? 1.9926 divided by 12 into 10 power minus 26 kg is 1.660 into 10 power minus 27 kg. Okay, so one atomic mass unit equivalent kilogram value is 1.660 into 10 power minus 27 kg. One atomic mass unit is nothing but 1/12 of mass of a carbon 612 atom. The mass of a single carbon 612 atom is 1.9926 into 10 power minus 26 kg. Divided by 12, 1.660 into 10 power minus 27 kg. So this is a value of one atomic mass unit in terms of a kilogram. In terms of a kilogram, right? Already I told mass of a proton is 1.6726 into 10 power minus 27 kg. The proton mass in terms of a kilogram is 1.6726 into 10 power minus 27 kg. Right. In terms of atomic mass unit, mass of a proton is 1.007276 U. Mass of proton in terms of kilogram 1.6726 into 10 power minus 27 kg. In atomic mass unit, the value of mass of proton is 1.007276 U. 1.007276 U. Right. Okay. Proton. And neutron, mass of a neutron value is 1.6749 into 10 power minus 27 kg. Okay, one neutron value, neutron mass value is 1.6749 into 10 power minus 27 kg. In terms of atomic mass unit, mass of a neutron is 1.008665 U. Okay, atomic mass unit of, the mass of a neutron in atomic mass unit is 1.008665 U. Right. Similarly, hydrogen atom, for hydrogen atom, whose mass in terms of atomic mass unit is, mass of hydrogen atom in terms of atomic mass unit is 1.007825 U. Okay. For electron, mass of electron in terms of kilogram is 9.1 into 10 power minus 31 kg. In atomic mass unit, mass of electron is 0.000549 U. Okay. So mass of carbon 612 atom, is 12 U. Mass of a single carbon 612 atom is 1.9926 into 10 power minus 26 kg in kilogram. In atomic mass unit, the mass of a carbon 612 atom is 12 U. Mass of proton kilogram value 1.6726 into 10 power minus 27 kg. In atomic mass unit 1.007276. For neutron, mass value is 1.6749 into 10 power minus 27 kg. In atomic mass unit 1.008665 U. For hydrogen atom, its mass in terms of atomic mass unit is 1.007825 U. And for electron, mass value is 9.1 into 10 power minus 31 kg. In atomic mass unit is 0.00549 U. So what is U? Atomic mass unit. What is meant by atomic mass unit? Atomic mass unit is defined as 1/12 of mass of a single carbon 612 atom. Right. What is the use of atomic mass unit? To express nuclear mass in nuclear physics, because it is very convenient to express the nuclear mass than other than kilogram, other than a kilogram, right? Okay, here how can you determine the value of mass of an atom, or how can you determine atomic masses? The atomic masses can be determined by using an experiment, by using an instrument called Bainbridge mass spectrometer. So Bainbridge mass spectrometer is an instrument which is used to measure atomic masses and as well as isotopic masses. Okay, isotopic masses also measured by using an experiment, by using instrument called Bainbridge mass spectrometer. Bainbridge mass spectrometer. So Bainbridge mass spectrometer, it is an instrument which is used to measure atomic masses, right? Then how can you calculate nuclear mass? Nuclear mass. Okay, it is possible to determine atomic masses by using an instrument called Bainbridge mass spectrometer. By using Bainbridge mass spectrometer, we can't determine nuclear mass. Then how can you calculate the nuclear mass? Simple. By subtracting the total mass of the electron from atomic mass, we can get the nuclear mass. Okay, so nuclear mass is equal to atomic mass minus mass of electrons, right? By subtracting the total mass of electron from a given atom, given atomic mass, we can get the nuclear mass. Because by using Bainbridge mass spectrometer, it is possible to determine atomic mass. Okay, because the atom includes the electrons. Atom include electron. If you want to calculate the nuclear mass alone, just we subtract the total mass of the electron from the atom, from atomic mass. So nuclear mass is equal to atomic mass minus mass of electron. And another one formula is there, that is the mass of nucleus. Mass of nucleus or nuclear mass is equal to A into M. Okay, so it is expression for mass of the nucleus, that is A into M. Here small m means mass of a proton, mass of a single proton. And what is A? Mass number. What is mass number? The total number of total number of nucleons present in the nucleus. The total number of nucleons are present in the nucleus, right? So an average, the mass of a proton or mass of a nucleon is given by 1.67 into 10 power minus 27 kg. Mass of a proton value is 1.6726 into 10 power minus 27 kg. And mass of a neutron is 1.6749 into 10 power minus 27 kg. Proton and neutron are combinedly called as nucleons. On average, the mass of a single nucleon is 1.67 into 10 power minus 27 kg. Okay, so for our convenience, in this nuclear mass expression, we take mass of a proton. So here M, mass of proton, and A is mass number. Mass number is nothing but total number of a nucleon. So by using this equation, we can calculate the mass of the nucleus. Or otherwise, just we subtract the mass of electron from atomic mass, we can get nuclear mass. Right, Ernest Rutherford from alpha particle scattering experiment was found that the volume of the nucleus is directly proportional to its mass number. So volume is directly proportional to mass number, and also he was found that the volume is the nucleus is assumed to be spherical in shape. So whose volume is equal to 4 by 3 pi r cube, where r is a radius of the nucleus. Right? Substitute V is equal to 4 by 3 pi r cube here. Therefore 4 by 3 pi r cube is proportional to E. 4 by 3 pi r cube proportional to E. Here 4 by 3 pi is a constant. Therefore r cube is proportional to E. Or r is proportional to A power 1 by 3. By taking cube root on both sides, this condition becomes r is proportional to A power 1 by 3. If you want to remove proportional, we should introduce constant, that is r0 into A power 1 by 3. Here r0 is a constant of proportionality. its value is R naught is equal to 1.2 Fermi. Right. What is F? Fermi. 1 Fermi is equal to 10 power minus 15 meter. 10 power minus 15 meter. And what is a mass number? So R is equal to R naught into A power 1 by 3. This is empirical relation for the radius of the nucleus. Empirical relation for radius of the nucleus. The equation is R is equal to R naught into A power 1 by 3. R naught into A power 1 by 3. The radius of the nucleus is given by the formula R is equal to R naught into A power 1 by 3. Based on this formula, one simple problem is there. That is, suppose calculate the radius of aluminum 1327 nucleus. Then given nucleus is aluminum 1327. Okay. Now we need to calculate the radius of aluminum 1327 nucleus. Right. By using this formula, we can calculate the radius of aluminum 1327 nucleus. Right. We know that R naught value is 1.2 Fermi or 1.2 into 10 power minus 15 meter. And the cube root of aluminum 1327 nucleus is A value is 27 and the cube root of aluminum 1327 nucleus is 3. Therefore, the radius of this nucleus is R is equal to R naught value 1.2 into 10 power minus 15 into cube root of aluminum 27 is cube root of 27 is 3. Therefore, the radius of the nucleus is 1.2 into 3, 3.6 into 10 power minus 15 meter. Right? The given nucleus is aluminum 1327. For this nucleus, we need to calculate its radius by using, based on this formula. R naught value is 1.2 into 10 power minus 15 meter and the cube root of 27 is 3. Right? Substitute R naught value and A power 1 by 3 value in this equation. We can get 3.6 into 10 power minus 15 meter. So this is the value of the radius of aluminum 1327 nucleus. Next, we go for the density of the nucleus. Right, what is the density? Density is nothing but mass per its unit volume. General formula for density, rho is equal to m divided by v. Okay, mass per its unit volume is called density. For a nucleus, the density of the nucleus is defined as mass of the nucleus to the volume of the nucleus. Mass of the nucleus to the volume of the nucleus. Mass of the nucleus. Okay, divided by volume of the nucleus. Volume of the nucleus. Right. Already I told the mass of the nucleus is equal to A into M, where A mass number of the nucleus and M mass of one proton. Mass of one proton. So mass of the nucleus is given by mass number into mass of one proton. Mass of one proton. And volume of the nucleus is 4 by 3 pi r cube. 4 by 3 pi r cube, where r is the radius of the nucleus. The radius of the nucleus r is equal to r naught into a power 1 by 3. R naught into a power 1 by 3. Therefore, r cube is equal to r naught cube into e. R is equal to r naught into a power 1 by 3. Here we need r cube. Therefore, r cube is equal to r naught cube into a. Right. Substitute r cube value here. Then volume of the nucleus V is equal to 4 by 3 pi. Instead of r cube, we can write r naught cube into e. Right. Therefore, the density of the nucleus rho is equal to mass of the nucleus is A into M and volume of the nucleus is 4 by 3 pi r naught cube into E. 4 by 3 pi r naught cube into A. Right, here A get cancelled. Therefore, rho is equal to M divided by 4 by 3 pi r naught cube. Right. Here M, mass of one proton, and R naught, constant of proportionality. Okay, substitute M value and R naught value here. Rho is mass of one proton is 1.6726 into 10 power minus 27 kg divided by 4 by 3, pi value 3.14 into R naught value 1.2 into 10 power minus 15 the whole cube. Right, after simplification we can get 2.3 into 10 power plus 17 kilogram meter power minus 3. So this is a value of density of the nucleus. The value of density of the nucleus 2.3 into 10 power plus 17 kilogram meter power minus 3. Right. So this value is a constant for all the nuclei irrespective of its size. That means the density of the nucleus is independent of the radius of the nucleus and also volume of the nucleus and also independent of its mass number. Okay, the density of the nucleus is of the order of 10 power plus 17 kilogram meter power minus 3. So because of this high density of the nucleus, the nuclear matters are in highly compressed state. That is, the nuclear matter means the nuclear particle or a nucleon. The nucleons are tightly bound to the nucleus of the atom. Okay, because its density is very high. It is of the order of 10 power plus 17 kilogram meter power minus 3. So density of the nucleus is nothing but the ratio of mass of the nucleus to the volume of the nucleus. Mass of the nucleus is product of mass number and mass of one proton. And volume of the nucleus is 4 by 3 pi R naught cube into A. By substituting M value and V value in this equation, we can get rho is equal to M divided by 4 by 3 pi R naught cube after simplification. Now substitute the constant value, we can get to 2.3 into 10 power plus 17 kilogram meter power minus 3. So this is a value of the density of all the nucleus. Right. So thank you students. So far we discussed about nucleus and properties of a nucleus, classification of a nuclei, and next atomic masses and nuclear mass, then finally size of the nucleus and density of the nucleus. Right. Just to go through all the topics. If you have any doubt, you call me or send messages to my WhatsApp number. Right. Thank you student. We will see you in the next class.